So data-driven decision making, right? And I'm not sure where I came across this, but I think I probably read it somewhere. I don't know who to attribute it to, but so data-driven decisions are just better decisions, and that's typically most of the time it's the case when you have a hunch, you have an intuition, and then you bring in data along with it to sort of have better confidence in whatever you're sort of embarking on, right? Uh, uh, so there are some things you want to sort of go through in the sense that whenever you are in the process of collecting data, right? We need to start off with it always starts with the question at hand, right? As to, okay, what are you trying to do? Are you trying to make a reduce cost in your business, right? Or are you trying to sort of use the sensor data to uh, uh, sort of monitor and sort of drive a decision? For example, I'm not sure where I read it, but there is this in New York City, in the sewage system, in the sewers, they use a lot of sensors to sort of predict or to sort of, and I think I have this example somewhere which I'm going to cover, where they sort of watch the amount of oil which is basically being discarded in the sewage system, and if there is an inordinately large amount of oil, they want to see whether there is an unlicensed restaurant basically which is dumping oil, right? So there are all the sensor data they sort of track. So basically, so in this case, in the New York City case, they know exactly what to look for. So they already have the problem defined. They know the question, so they know what sensors to put in place to collect the right kind of data, right? So of course, experience and intuition matters most here, right? Uh, and many companies collect data that is available rather than the information that is needed to help them make effective decisions, right, and run businesses more effectively. So the starting point always, whenever you are in this data role, should be to be clear about a limited number of key questions that you want the data to help answer, and focus the data collection efforts around them, right? So rather than having starting with whatever data is in front of you, you need to sort of hone in what data you need to help answer the questions or question, or what data you need to solve the problem at hand. Okay, and and that could be like reviewing, and part of that thing could be also reviewing previous findings, is if available. Industry focused research helps, whatever domain you are in, you would want to have a good understanding of what's going on over there as well. And then comes like so these are basically some of the steps, right? Just thinking out loud, some of the things you want to sort of keep in mind, right? Variable selection, solution modeling, okay, and formulating a like so. What that probably entails is like formulating a detailed hypothesis about how particular variables affect the outcome. Okay, so you're going to have a bunch of variables on the right hand side of this equation, right? Where you have the outcome variable on the left. So, say for example, in the case of New York City, the outcome variable is making sure that the sewer system remains clean with respect to all this restaurants dumping unwanted stuff into the system, right? So that's your outcome variable. So you're monitoring that. Or in the case of say the restaurant business we covered, the outcome variable in that case is sales or profits or whatever it is, or whatever the measure is, right? So your task is to use rigorous methods to test your hypothesis, right? So whatever your hypothesis is, you want to say, so your hypothesis could be, what if I increase this marketing spend, or what if I increase this promotional effect or promotional campaign? What is the impact of that on my outcome variable, which could be sales, right? And and uh, and 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 data cleaning, and that sort of follows into data collection, cleaning, and merging, and this is where you'll probably spend the most of your efforts, right? So does your data tell a story, right? and most data comes in fragments, right? Which to be useful, these individual bits of information need to be put together into like a coherent explanation of the business situation, which means integrating data from different sources and bringing that into like a cohesive story that could be expanded with supporting analytics, right? And a big issue with this thing is whether the data you get is clean and easy to analyze, right? And data in general comes in two forms. It could be structured data and unstructured data. Structured data is where you have clean data with rows and columns of data where there is not a lot of tweaking you have to do, but that's not reality, right? In reality, you'll be dealing with unstructured data almost all the time, okay? And it's basically free form and hence cannot be easily stored in the type of typical relational databases most commonly used in enterprises. So before the data gets fed into those databases, there is a huge amount of effort which sort of is entailed in terms of cleaning and managing the data before it's fed into like a relational kind of a structure, right? And according to a report by professors Amir Gendomi and Murtuza Heather of Ryerson University, unstructured data basically forms 95% of the world's data, and many large companies for many large companies storing, manipulating, and this type of data requires a significant amount of investment of resources to extract necessary information, right? And even if data is structured, right? So I personally deal with situations where I am told that, hey, this is the clean data you want, and I go into this data, there's like missing information, there's information which I'm expecting a numerical kind of a situation, and I get text-based data and all those things. So you have to still sift and put quite a bit of effort. I still end up spending quite a bit of effort, even with structured data, right? So it may still need to be clean, checked for inconsistencies and inaccuracies, right? And lack of data quality and completeness is a huge issue. And unfortunately, unless your systems are data quality aware, right, you will be left holding the bag of ensuring data integrity for analysis, right? And you don't have clean data, you cannot run any of this analysis, right? And the next step, of course, is once you have the data, it's all statistical modeling and building maybe learning models on top of the data, right? So you'll and that's where you can use a lot of these open source tools and statistical techniques, but simplicity is often the best choice, right? And there is this concept called underfitting versus overfitting onto a data set, right? And the more you try to overfit, the more you try to make your models complex, the more likely that you might be able to make your models work within a data set. But when you go out of that data set or out of sample versus in sample, working on using that model on out of sample data, you will get some erroneous predictions which might not be as useful. So you want to be always careful as to how much complexity you add to your models, right? So start simple and add complexity if simple doesn't cut it, right? And of course presenting your findings and storytelling, right? So using the data to tell a story to decision makers and stakeholders for possible action, right? That's where most of the action is. You can do all the analysis you want, but if there is no decisions that can come out of that, then it's basically all not worth it, right? And the most important thing about that is that does the data help the organization to look forward instead of back, right? You need your analysis to sort of help steer the organization in the path you want the organization or whatever that process or that project you're working on to move forward instead of looking back, right? And of course, when you are basically presenting your findings, you should have questions, and even intuitively internally, you should know you should have answers to some of the questions like what was the source of the data, right? How well do the sample, as I said, most of the time you're going to be dealing with sample data, and how well does it represent your population, right? Uh, so and does your data distribution include outliers, and how would they impact your results? Are you accounting for the outliers? Are you taking them out? And how would the inclusion of those outliers basically will impact your results, right? What assumptions are behind your analysis, right? Might certain conditions render your assumptions and your models invalid, right? And that could be the case in many situations where you're where you're building a model for, let's say you are not factoring in seasonality and you don't have probably seasonal, like I sometimes deal with situations where I'm sort of trying to build a model on predicting price, and then I have some volume information which is inconsistent, right? uh, uh, if I don't have a good volume information, and you know that price and volume, right? For example, if I'm building a product, right? If I'm building 1,000 units versus a million units, the price per unit for 1,000 unit is going to be way different than price per unit for a million units. So if I'm not properly accounting for that volume information, then my model technically is not valid, because it doesn't mean anything, right? Because you are missing that key information, right? And 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 you can use many different types of approaches. We are going to cover two broad aspects of dealing with either a continuous variable type of prediction when it comes to predictive analytics, when we get there, a continuous variable type and a dichotomous or a categorical variable type of prediction. We're going to get into that as to what these two means. But uh, but why did you choose this? What alternatives did you consider, and so on? So you should have a good answer to all those kind of questions. And uh, and and the most important thing is the variable selection part, the parameter selection. How likely is it that the independent variables you have are actually causing the changes in the dependent variables, right? um, and causal, and I always believe in causality, right? And the world is moving away, at least in the big data world, and sometimes and we're going to cover that as to why sometimes it matters, sometimes it doesn't. But causality is good, right? If you can sort of prove a causal relationship between a variable which is causing the outcome variable you're trying to measure, right? If you have an understanding of the causal relationship, that's the best of everything, right? So that's about it for this. We're going to move on to the next video. Okay.